Hi everyone, and welcome to Astro at Home, presented by Discover the Universe. My name is Lindsay Mann, and I'm very excited to bring you a new topic today and a new speaker. Before we get to that, though, I'd like to remind you of some of our house rules, primarily about the chat. So if you're watching us live right now, we ask that you not spam the chat, which is to send several messages at once, and it fills up the whole bar. And we ask that you stay respectful of one another. If you break those rules, then we will put you in a timeout, which means you won't be able to ask questions for about 5 minutes, which is very unfortunate because we love to get your questions and we love to hear from you. Today, we are joined by Professor John Percy with the University of Toronto, and he's going to give us a tour of the universe. He has been working in astronomy for a very long time, and I'm sure he's got lots to share. So I'll invite John to join me here, and we can get started today. Hi, John.
Hello, can you hear me?
We can hear you great.
Okay.
I'll hand it over to you.
Yeah, just give me 1 minute here. Okay.
Perfect.
We all set?
Yep, we're good.
Okay, hello everybody out there. I'm John Percy. I've been an astronomer and astronomy teacher for over 50 years, and I love it. Now, first of all, what is astronomy? It's almost everything. It's the study of the nature, origin, evolution, and fate of the universe and everything in it: galaxies, stars, planets, moons, the whole shebang. Now, when I was your age, I used to read science fiction. One of my favorite science fiction writers was Jules Verne from about 150 years ago. And this is how he thought that we would get into space: on a giant bullet shot from a cannon from the Earth to the moon. Unfortunately, it doesn't work that way. Now we know that we need a lot more effort than that. We use giant rockets like this to send people into space. And that started to happen around the 1960s or a bit earlier, just when I was a little bit older than you are. So with rockets like these, you first would go into near Earth space, that is a couple of 100 kilometers up. And you've probably seen pictures of astronauts like Chris Hadfield here, just drifting around in the spacecraft, weightless. But one thing I'd like to emphasize is that he's not gravity-less. There's gravity up there almost as much as there is down here. And believe it or not, he and the space station are actually falling to the Earth. But because they're going sideways, they're falling around the Earth in an orbit. Well, if you want to go to the moon, you've got to exert some more energy to go from 200 kilometers up to the moon. So this is where we're starting. This is our Earth, and you can see its blue oceans and its continents, its white clouds and so forth. This is what our planet looks like. So back in the 1960s, when humans were first going to the moon, they first sent spacecraft there to look for a good landing site. This was one of the pictures that was taken from orbit of the lunar surface. And what you see in front of you is a huge round valley called an impact crater. And this was caused by a gigantic space rock that crashed into the moon billions of years ago. This is actually about 75 kilometers across. Well, finally, humans went to the moon, and in July 1969, the first human stepped on the moon. I remember watching it in my basement on an old television set. And so this lasted for a few years, but humans have not been back to the moon since then. In fact, this is as far into space as humans have actually gone. So anything more than this, you have to have a spacecraft or a telescope or something like that. So let's start at the center of our solar system with our sun, a star. It's 1 million times bigger than the Earth. It generates energy at the rate of 400 million watts. And it's been doing that for 4.5 billion years, and it will continue to do so. So traveling outward from the sun, we get to Mercury. You notice Mercury is completely covered with these round valleys, impact craters. It has no air, no water. It's completely lifeless. It's very similar to our moon. But then the next planet is Venus. This is Earth's evil, shrouded twin sister. It's shrouded in clouds made of sulfuric acid. And if you were to peel those clouds away, like on this radar image here, you'd find that surface temperature was 450 degrees, hotter than your kitchen oven. The pressure of the atmosphere would be 100 times the Earth. You'd be crushed. Now, one interesting thing about Venus is that all the surface features are named after women, with one exception. And this is my favorite. This is Miss Piggy from the Muppet Show here. And you'll notice that her nose and her eyes and her ears are actually just round piles of solid lava that's come out of little volcanoes on the surface. So that's Venus. Now, we're going to go past the Earth, but this time we're going to go past the Earth on the night side. And now we see the whole of North America lit up by the lights of cities. You'll notice in the bottom right is Florida sticking out into the ocean. And if you're really careful, you can see towards the, just underneath the Canadian flag are the Great Lakes, including Lake Erie, Lake Ontario, and the Golden Horseshoe. So we'll pass by the Earth and we'll go on next to the planet Mars. You'll notice it's red, and that's because its soil is rusty. You'll notice at the top and bottom, there's light colored polar caps, and these are frozen carbon dioxide. And Mars is not very habitable right now, but one thing we've learned is that billions of years ago, Mars was actually warm and wet and possibly habitable. And on this picture here, all those streaks there, those are ancient river beds where water once flowed on the surface. Nowadays, Mars is cold and dry. This is a picture taken from one of the rover spacecraft sitting on the surface of Mars. You'll notice that the surface is reddish. You'll notice the sky isn't black like it is on the moon because Mars does have a thin atmosphere. And possibly somewhere on Mars, there's evidence that maybe life formed there billions of years ago. Moving on outward, the next thing we find is a whole belt of asteroids, or tiny planets. So this one is the largest. Its name is Ceres. It's about the size of a province. And on the left, there's a picture of its surface, lots of those round impact craters where it's been hit by smaller space rocks. And on the right-hand side, a picture of what we imagine it's like, maybe with a layer of water ice beneath its crust and then a rocky core underneath, something like the Earth, but much smaller. But most of the asteroids actually look like this. They're very small. This is about the size of a city, and they're quite irregular. And you'll notice that there's lots of little impact craters. This one's probably a broken up asteroid that was originally of a larger size. There's also comet nuclei. Comet nuclei are made primarily of ice. This one is also about the size of a small city. Usually these things are in the outer solar system, but if they come close to the sun, the ices evaporate into steam, and then the sun's radiation pushes away a tail. That's what we normally see in a comet, but this is the heart of it here. What happens if one of these asteroids or comet nuclei hit the Earth? Well, this is what happens. A huge impact crater in the middle of Quebec. This formed about 200 million years ago. These impacts, fortunately, are not very often. The largest, the most recent big one was about 65 million years ago in what's now Mexico. And that resulted in the extinction of over half the species on Earth, including the dinosaurs. So moving on now, beyond the asteroid belt, we find the gas giants, including Jupiter. Jupiter is 1,000 times bigger than the Earth. Right in the middle there, you see that red colored oval. That's a permanent cyclone in the atmosphere of Jupiter. The thing at the bottom right there is one of its moons. Its atmosphere is made mostly of gases like hydrogen and helium and water and methane. And Jupiter has lots of moons. This is one of them. You'll notice to the top left there, there's a volcano actually erupting into the blackness of space. And Io is made, the surface of it is made mostly of forms of sulfur in different colors. It looks like a gigantic pizza. And then the next of its satellites, Europa, is interesting because it has a crust of ice, but we know that beneath the crust of ice, there's a layer of water where possibly some simple life form could have been produced. And then that's over top of a mantle and core of rocky material, something like our moon. In fact, this moon here is very similar to our moon in size, but of course is quite different in its surface. The next of the planets is another gas giant, Saturn. And Saturn's a bit smaller than Jupiter, but otherwise very similar, except look at this wonderful system of rings orbiting around the planet above its equator. So you've probably all seen pictures of the rings of Saturn. Maybe you wondered what they are. Well, this is what they are. They're millions and millions of ice balls about the same size as you are, all orbiting around the planet above its equator. They're probably the remains of a comet nucleus that came too close to to Saturn, and broke apart. The other thing that Saturn has, it has a moon Titan with a thick atmosphere. This is the only moon in the solar system that has an atmosphere. So on the top left there are drainage patterns, but they're not drainage patterns of water because the temperature here is 180 below zero. Those are drainage patterns of methane and ammonia, which at the temperatures here can be solid, liquid, or gas. And you can see pictures on the center and right of the blocks of ice sitting on the surface there. This spacecraft actually dropped into the atmosphere of Titan and took all of these wonderful pictures. So another of the moons of Saturn is Enceladus, and it's made mostly of ice. And on this picture here, mostly you see the dark side of Enceladus, but on the left-hand side there, you see volcanoes of water vapor spewing into space. So that would be a good place to stop and get some water before you proceed on to the next stop, which is Uranus and Neptune. They're intermediate in size between the Earth and Jupiter and Saturn. We call them water giants. That's because there's water vapor as well as hydrogen and helium and ammonia and methane in their atmospheres. Otherwise, they're rather boring planets. Then we get to poor little Pluto. Pluto used to be the 9th planet when I was in school, but then it was discovered that Pluto was really very small, and so it was demoted to dwarf planet. On the right here, you see a picture of Pluto with its large moon Charon and 2 of its smaller moons. And on the left, you see a wonderful image from a flyby spacecraft. You see a light-colored heart feature, which is actually a glacier of solid nitrogen. Around it are mountains of icy material. So quite different than our moon or our planet or anything like that. So the spacecraft that took this picture went on into the outer solar system and took this picture of the most distant place in our solar system that's been visited by spacecraft. These are 2 ice balls that are stuck together. Each one of them's about the size of a city, and their nickname is Ultima Thule, which just means very distant object, but their name Arakoth is actually an indigenous language meaning sky. So beyond this, spacecraft have not yet visited. Just to put all of this into perspective, if you made a scale model of the solar system in which the sun was a beach ball, then the solar system model would be a few kilometers in size, but the next nearest star to the sun would be in Australia, a long way away. So in order to go any further, we can't use spacecraft. Go on into our Milky Way Galaxy of hundreds of billions of stars, and the tool that we use is a telescope. So astronomers have these huge telescopes on the tops of mountains. This one is Mauna Kea in Hawaii, and those are to take images and make measurements of the distant stars, galaxies, and other things that are in space. So if we went on our trip into the Milky Way, the first thing we would encounter is the nearest star to the sun, and we'd immediately see it's actually a double star. It's actually a triple star. The third star is off the field of view of this, and turns out that double stars are quite common. So here are three interesting objects that we would soon encounter. On the left-hand side is the double-double. It's a pair of double stars orbiting around each other. So Tim Hortons didn't invent the term double-double. In the middle, we see a star Albireo, which marks the head of the swan, Cygnus the swan. And you'll notice that not only is a double star, but one star is orangish and the other is bluish. The orangish one is cool and the bluish one is hot. And then on the right-hand side is the amazing star Betelgeuse, which is actually as big as Jupiter's orbit. So if you put that where the sun is, it would swallow up all of the inner planets, including the Earth. So that's what's called a red supergiant star. We'd find out how the stars were formed. Here's a whole cluster of stars forming from a huge cloud of gas and dust called a nebula. You can see them there. There's hundreds of them, bluish colored there. And if you zoomed in close up, you might see a solar system like ours forming. This is an artist's conception of what the formation of our solar system would have looked like 4.5 billion years ago, with the sun forming at the center and a disk of leftover gas and dust. And in that, the planets are slowly forming, and they give us the 8 planets that we have today. We would expect, according to this, that any star that formed would have planets around it. And actually, that's what we found. This picture here looks rather strange because all that fuzzy stuff in the middle is actually the light of the star, which has been suppressed by about 99.999%, so that we could see the very faint planets, B, C, and D, that are orbiting around it. So those 3 planets, B, C, and D, are slowly orbiting around this particular star. We find that planets around other stars are very common. In fact, the nearest star to the sun, this is the third part of Alpha Centauri, we call it Proxima Centauri, not only has a planet, but it has an Earth-like planet. So this is an artist's conception. The planet is on the right there. On the left is the star itself, which is called a red dwarf. And that planet would actually be warm and wet enough for life to form, perhaps. We might see some beautiful star clusters like the Pleiades or the Seven Sisters. Here it's illuminating the dust around the stars like angel hair on a Christmas tree. Or we might see this huge mega cluster, a globular star cluster. This is one of the oldest objects in our galaxy. It's 12 billion years old. And you might notice that the brightest stars in it there are reddish. And the reason for that is that they are red giant stars. When our sun runs out of energy billions of years from now, it's going to swell up into a red giant star. It will engulf the orbit of Mercury and Venus and stretch almost out to the Earth. The Earth will dry up completely and become very hot. But that's billions of years in the future. That's how our sun will end its life. And the expanding atmosphere will drift off into space, producing these beautiful planetary nebulae. That's what they're called. And you notice that every one of those has a tiny little star at the very center. And that's the remains of the star that's just died. So on the top right, that's the Ring Nebula. The bottom right is the Dumbbell Nebula. Bottom left is the Eskimo Nebula, and the top left is called the Cat's Eye Nebula. However, there are very rare massive stars which, when they die, their cores collapse under their own weight and release so much energy that the rest of the star explodes in a supernova. And all the chemical elements that have been made in the centers of stars, like the supernova, get spewed out into space, and then it become part of the nebulas from which new stars form. So all the atoms in your body, everything except the hydrogen, was actually created in a star, exploded into space like this, and then became part of the nebula from which our sun and Earth and so forth all formed. So you are star stuff. Now, there are very, very, very rare massive stars that when they come to the end of their lifetime, they collapse under their own weight and become so dense that nothing can escape, not even light. And that's called a black hole. In this picture here on the left, that's a normal star with a black hole companion, that black thing in the middle of the disk on the right there. That's the black hole. And gases are swirling across from the normal star onto the black hole, making it light up. And that was actually discovered right here in Canada at the Dunlap Observatory, Richmond Hill, Ontario, just north of Toronto. What we can't see in our galaxy is something called dark matter, which actually makes up most of the mass of our galaxy. So it's some kind of invisible elementary particle or something like that. And this is one of the great problems that astronomers are trying to solve. The other interesting question is, at the very center of galaxies like the Milky Way, we find a supermassive black hole, millions of times more massive than the sun, which somehow formed in the early days of our galaxy's history, 10 or 12 billion years ago. Another mystery for people to solve in the future. So now we're going to head out of our Milky Way galaxy over to our nearby neighbor, the Andromeda Galaxy, which is very similar to our galaxy. It's 2 million light years away. That means that to get there, it would take us 2 million years traveling at the speed of light. The other thing that means is that the light from the Andromeda Galaxy has taken 2 million years to get from there to here, so we see it as it was 2 million years in the past. We can actually look back into the past. That's one of the great things about astronomy. And our galaxy and the Andromeda Galaxy are slowly coming together, and in 10 billion years, they're actually going to collide. Actually, they'll just pass right through each other and merge into a larger galaxy like these two galaxies here are doing. Galaxies exist in large clusters. This is the huge cluster of galaxies here. And you may see on certain parts of the picture, there are little wisps, little wisp-shaped objects. Those are actually the images of more distant galaxies that have been bent and distorted by the huge gravity of this cluster of galaxies here. And that brings us to one of the most amazing pictures that astronomers have ever taken. And this is taken by the Hubble Space Telescope. It's a time exposure looking deep into the universe. And with one exception, every point of light on this picture here is a galaxy of hundreds of billions of stars. Some of those galaxies are so far away that it's taken billions of years for their light to reach us. So we see them as they were billions of years ago. So we're actually looking back towards the birth of our universe. So our universe came into existence, and space and the galaxies in it have been expanding like this balloon here. So it's not that the galaxies are moving, it's that the space that they're fixed in is slowly expanding like these balloons are. So I keep referring to the birth of the universe. Can we see it? Well, yes, if we look far enough out into space, we're looking back in time. And if we get back to 13.7 billion years ago, what we see is this. This is a map of the sky. This is the material of the universe, 400,000 years old. And the orange parts there where the material is starting to come together and to form the galaxies and the clusters of galaxies. So this brings up the last question is there life out there? Are there space aliens? I could spend a lot of time talking about this, but I'm just going to show you this one slide here to emphasize that in the universe, there are billions of galaxies, each of them with hundreds of billions of stars, most of them with planets, some with planets that are like the Earth, all made out of the same stuff as the Earth is, and all obeying the same laws of science. We even know that the building blocks of life can form naturally and easily, even in interstellar space. So something to think about, and thank you for coming on this tour here. And now it's question time. Thank you.
All right, so I do have some questions that stem back to the beginning of our conversation. The first one is, how many spacecrafts are there in space?
How many spacecraft? Well, that's a complicated question because it depends what you count as a spacecraft. There are literally hundreds and hundreds of satellites orbiting the Earth, and there are more and more every week because there are communication satellites, there are satellites for GPS systems and so forth. There's only one up there that's actually inhabited. That's the International Space Station. There's also dozens of spacecraft that have gone to other planets. There's spacecraft that are on their way out of the solar system. There's ones like the one that took pictures of Pluto and of Ultima Thule and so on and so forth. So lots and lots. Plus there's probably some that are top secret because they're military satellites.
Fair enough. Next question. I don't know if you'll have an answer to this one. When will we be able to make use of hyperdrive or light speed?
You mean some of those things that science fiction writers have developed?
Yeah, I think so.
It's difficult to answer that question because these are things which, according to the laws of physics now, simply cannot exist. They defy the laws of physics. So my initial guess is that we would never be able to use that kind of technology. Certainly some of the technologies that science fiction writers have come up with, we use those technologies every day. But in my opinion, ones like that, and that includes things like wormholes and other things, those I don't think we're going to ever use.
Right.
But you can find me wrong.
Maybe the future will.
Yeah.
Okay, one participant said, I thought the hurricane on Jupiter was dying. Is it permanent or will it go away?
You mean that the great red
big
spot?
Red spot, yeah.
It might possibly be. It hasn't died yet, and it's been around for several hundred years. So I wouldn't want to predict that it will permanently go away because we honestly don't know how these weather systems develop in a long time scale because we've only been observing Jupiter closely for a few decades. So maybe it will go away because if you look at Jupiter or well, particularly Jupiter, you find lots of other similar features, though none as large as the great red spot. And maybe they do come and go. But boy, the red spot's been around for a long time. I wouldn't count it out.
Okay, next question is, does it really rain diamonds on Neptune?
Does it really rain diamonds on Neptune? I don't know. It's one of these interesting ideas. I think that idea is a little bit overblown myself. Because the atmosphere, I mean, the atmosphere of Neptune is mostly rather simple gases. Yes, there is some carbon in them. So I can't rule out that there might be tiny little diamonds. I mean, one thing that we know is, and the universe is a really weird place, but I showed you those pictures of what happens to the sun after it grows old and runs out of energy, and then you get those round planetary nebulas with the tiny things at the center. Those tiny things are called white dwarfs. They're stars that are so dense that one teaspoonful of material would weigh about 1 ton. And most of the material in those is actually carbon. So the carbon actually gets crushed, and in a sense, it's kind of like a diamond, but not really.
Fair. They were very curious to know what your favorite planet is.
My favorite planet?
Mm-hmm.
Well, I wouldn't want to play favorites, but obviously the Earth is pretty useful.
True, yeah.
I'll go with the Earth.
It's a good choice. Somebody asked, is Alpha Centauri habitable?
What about it?
Is it habitable?
Do you mean the Earth-like planet around Proxima Centauri? Yes.
They said Alpha Centauri.
Alpha Centauri has 3 components to it. It's a triple star. And the smallest component, that's the one called Proxima Centauri. That means near, because it's a little bit nearer to the sun than the other 2 members are. And it's defined as an Earth-like planet because it's at the distance of its star such that the temperature on the surface is more or less like it is on the Earth. Water can exist as a liquid, which is very important for the development of life because life initially develops in a liquid environment. You need that to have biochemical reactions and so forth. So when we talk about an Earth-like planet, and there are many around nearby stars, we mean ones where the temperature is more or less the same as what it is on the Earth. Now, among the thousands of planets that have been discovered outside our solar system, some are really quite weird. Some are like Jupiter, but very, very close to the star. And so we call those hot Jupiters. Then there are things called super Earths, which are something like the Earth, but larger. And then we have ones that are kind of intermediate between the Earth and Uranus. We don't have any of those in the solar system. So what the discovery of these planets has done is to provide us with a huge number of different kinds of planets, some of which we never knew before. So my colleagues at the University of Toronto, some of them are working actively studying these distant planets and finding out what they're like and whether any of them could possibly have life on. Because if, for instance, we found a planet that had oxygen in its atmosphere, the only way you get oxygen is if there are plants there to produce it, because otherwise the oxygen just reacts with the soil to produce rust.
Okay. I guess, yeah, it's a more complicated question than just answering yes or no.
Astronomy is very complicated.
Yeah. The next question was, what is Andromeda?
Andromeda. Well, Andromeda is actually one of the 88 constellations of stars that we recognize. And the Andromeda Galaxy is called that because it happens to be in the direction of the constellation Andromeda, but much, 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 much further away than the stars that make up that particular constellation. So the Andromeda Galaxy is not only interesting because it's the closest big galaxy to our own galaxy, but it's also very similar to our own galaxy. They're what's called a spiral galaxy. They're kind of disc-shaped and the stars move in a kind of spiral pattern around the central part of the galaxy. So by studying this nearby neighbor, we can learn a lot about our own galaxy as well. So it's a very important galaxy. And in fact, in a clear, dark sky, you can actually see it with your unaided eye. It's even better if you've got binoculars.
Perfect. The next question is a universe and a galaxy the same thing?
No. The universe is everything that exists. So it includes all of those tens of billions of galaxies and all of the things that are in the galaxies. There's not very much material between the galaxies, but what there is lots of energy, starlight. There may even be something, well, there's the space in which the galaxies exist. And there's something very strange in the universe that's making the expansion of the universe speed up. Right now, since we don't know what it is, we call it dark energy, but we don't know what it is, but it's a part of the universe, a very important part. Whereas the galaxies, of which there are tens of billions, are these large families of stars like our own that are bound together by their gravity. So that's the difference.
Perfect. I missed the context for this question, but I think you'll know what they're referring to. They're asking, how do we know that it is 13.7 billion years?
That is a really, really good question. How do we know that the universe is 13.7 billion years old? Well, the simplest way is from the expansion of the universe. We observe that the universe is expanding. And the famous astronomer Edwin Hubble was the one who discovered this, so while he's building on the work of astronomers before him. And so the fact that the universe is expanding means that we could project that motion back in time, and we'd find that everything in the universe was together about 13.7 billion years ago. But there's actually a whole bunch of other methods. They're much more complicated methods that we can use. And actually that picture that I showed you of the birth of the universe as it was 400,000 years ago, my cosmologist colleagues can derive the age of the universe from that. We also know, for instance, that globular cluster that I showed you, of which there's 150 in our galaxy, they're about 12 billion years old, and they're the oldest thing that we know in terms of stars or galaxies. So we put a whole bunch of pieces of information together. We know, for instance, that the Earth is 4.5 billion years old. We can measure the ages of the different star clusters like the Pleiades and so forth. So we have a huge amount of information about the universe and the things in it. It all fits together with this idea that the universe is about 13.7 billion years old.
Thank you for that. The next question is it possible that a star that we can see has already exploded?
That's a good question, and it's one that I hear very often. And one way of answering that is to tell you a little story about that star Betelgeuse that I showed you the picture of, because it's one of the brightest stars in the constellation Orion, which has been around all winter and is now disappearing into the west. Well, at the end of 2019, astronomers, particularly amateur astronomers, noticed that it was actually fainter than it had ever been before. And so somebody picked up the idea that, well, maybe that means that it's about to explode as a supernova. Well, if it exploded as a supernova, then it would actually have exploded about 1,000 years earlier than that, because Betelgeuse is about 1,000 light years away. We're looking back in time. So it is conceivable that if we had observed that star a year ago and it looked normal, that it had actually exploded 1,000 years before then, and we wouldn't learn about it until the end of 2019. Well, anyway, my research shows that it didn't get faint because it was going to explode as a supernova. There was a perfectly good other reason why it was getting faint. The key point here is that the lifetimes of stars are millions or billions of years. And in the short period of time that it takes their light to get to us, not really very much is going to happen to those stars. The chances are pretty low.
Right, that makes sense. We just got 2 more questions to get through. The next one is, what galaxy is bigger, the Milky Way or Andromeda?
Andromeda is slightly bigger, but not significantly so. That we normally say that they're very similar to each other, but I think the latest figures are that the Andromeda Galaxy is slightly bigger. Most of the things that we measure in astronomy, we can't measure with perfect accuracy. Things are getting better every year. I mean, I know that from being an astronomer for 50 years, and there are marvelous space missions and telescopes and things like that that mean that we know things more and more accurately all the time. But for instance, in the case of Betelgeuse, there's still uncertainty. How big is it? How massive is it? How far away it is? And that's for perfectly good reasons. Last question.
The last question, do we know of anything that is faster than light?
The answer is very simple. Nothing travels faster than light. This was a key part of Einstein's special theory of relativity, one of the most important scientific laws ever developed. And that plus his general theory of relativity. There's been many, many experiments and observations that have shown that, that those theories are correct. So according to what we know, nothing will travel faster than the speed of light for all practical purposes.
Great. Thank you so much for answering all the questions. I think you did an excellent job of giving us a great tour of the universe, especially of our solar system and our Milky Way. I think the kids didn't have a whole lot of questions because everything was beautifully explained. So I'm very pleased to have had you join us today. And if you guys in the chat would like to show some appreciation for John's presentation today, please send us some of your favorite emojis that are related to space, and we'll make sure that he sees those.
Okay. Thank you very much.
Thank you. A couple little final notes is if you guys want to do more science education activities at home, we have links in the description box below to other programs that are going on that you can take part in. We've also created a survey because we'd like to know a little bit more about you guys. So if you can take a minute, just click in the description box. You'll see there's a survey link there. We're just curious about how old you are, where you live in Canada, how many people are watching with you, that kind of thing. It'll help us understand what kind of programming we should continue to develop for you guys. It won't be able to link back to you, so you don't need to be worried about sharing personal information, but if you're curious or nervous at all, you can definitely ask a parent to help you with that. And if you haven't already, give a thumbs up to this video, subscribe to our channel, and click the notification bell so that you know when we're online again on Monday. So we are taking a break for the weekend, and we'll be back on Monday to talk to you guys about telescopes. So thank you so much for joining us today, John, and thanks for everybody who watched live. And we will see you on Monday. Bye.
Bye.